Hello, welcome back to WebinTech. In this video, I will show you how to create an ETL pipeline using Azure Databricks and Azure Data Factory. Before moving any further, let's go through all the resources that are required to perform this task. As you can see here, these are the list of tables that we are going to use to do some ETL transformations on the data. And this is the lookup table or the metadata table, which contains all the information about the source table name and the folder in which that we are going to place the intermediate files to process the data, and all the other details like incremental load or historical load, some other details that are required in near future. So we'll use this lookup table whenever it is necessary to do some operations. So let's go ahead and start creating the first pipeline. We will accomplish this task of doing some ETL transformations by doing first extraction from the source. As we know that we have our data at source in multiple tables. So these are all the 6 different tables that we have at the source, and I have ingested some amount of data into each and every table. For timing, I'll show you a couple of them. The data is very less, it's like 2 to 3 records in each and every table. So if you see here, these are the 3 tables. Let's query them for now. And as you can see here, we have some data ingested into these 3 tables, and similarly we have data in other tables too. And let's extract the data from the source and place it in an intermediate staging table or the staging area, from where we can pick it up into our Databricks workspace and do some transformations using PySpark and SparkSQL. So first, in order to extract the data from the source, I'll use Azure Data Factory pipeline. I'll create 2 pipelines. One is for historical data pull and the other one is for incremental. I'm not showing any variation between the historical and incremental for the time being in this video, but in future I will show you how to pick up the data or pull the data specifically for incremental pipelines or the incremental loads. So I'll accomplish the task of extracting the data by using a lookup activity, because I don't want to create multiple pipelines for each and every table to extract the data from source for each and every table. So instead, what I'll do is that I'll parameterize the table details, like what is the source table and from where it has to extract the data from. So I'll use a lookup activity in the Azure Data Factory, as you can see here, and I have created a dataset and a link service. Considering you are aware about what is a link service and a dataset, I am not explaining much more about each and every component of those. Each and every definition of those, what is a dataset and a link service. So I have created a dataset and a link service for this lookup activity. Since my metadata is present in the SQL database, I have created this is the table that we have the metadata information. Okay, so I want to get this 6 records into my lookup activities output, so that I can parameterize what is the source table and from which table the data has to be extracted. So I have provided the query option, and I have provided the query, and since I have created 2 different pipelines, one is for historical and one is for incremental, I am specifically mentioning what is the load type, so that if it is a historical pipeline, it will extract the data only for the tables that have load type as H, which means the historical load. See, I have 3 tables as load type H and 3 tables as load type I, which is for incremental. So we are done with the lookup activity. So the output of this lookup activity we will be using as input to this for each activity. So I can achieve this task by providing the output to items property here. So the output of this lookup activity, whatsoever it is, will be fed as input to this items property in for each activity. and we'll use an item function in each and every iteration of this for each activity. So for example, we have 3 tables that have load type H, right? So in each and every iteration, which means we usually get 3 records as output for this lookup activity, which means this for each activity will iterate 3 times. So in each and every iteration, the for each activity will take the first record as the input for this and iterate over the data or whatsoever the activity that we will mention inside this for each activity. So basically, we are providing the output of this lookup activity to items property in for each activity, and in order to use this output of this lookup activity inside the activity of this for each activity, we will use item function. You will see it in a moment. So inside this for each activity, I have placed the actual copy data activity, which will extract the data from multiple table sets from source and place it into Azure Data Lake Storage Gen 2. Let me show you the storage account that I have created and the container in it. This is my storage account, Sales Analytic, and inside containers, Sales Analytics is my container. As you can see here, I have tested this earlier, and which is why you are seeing 3 different folders. For time being, you just ignore the sales folder. Consider only these 2 folders, that is historical and incremental. So inside historical, I have again 3 subfolders. One is for payments, lookup ADL as stage 1, products ADL as stage 1, sellers ADL as stage 1. So which means, as you can see in the database table, I have historical load. Load type as H for 3 tables, that is for products, sellers, and payments lookup, which is same as the folder names here, right? So I have parameterized these parameters that I have got from the lookup activity dynamically, which will automatically provide the folder names dynamically when the pipeline is running. Don't get too bothered about what exactly is happening. Just when we go with the flow, then you can understand over the period. So as you can see here, we have some data inside it. See, we have some data, right? So what we are trying to do is that we are trying to extract the data from the source and place it in our storage account, from where we will onboard or load the data into a Databricks workspace and use this data to do some transformations on it using PySpark and SparkSQL. So for time being, let's move further and let's delete these 2 folders. Okay, so let me explain you the copy data activity. So my source is obviously the SQL database, and I'll show you my data set. So I have defined 2 parameters. One is for schema, what is the source table schema, and the one is for source table name. I have declared 2 parameters, and I have initialized them here using the dataset function. And coming to the sink, my sink will be ADL as Gen 2. So I have created my data set for ADL as Gen 2, and I have provided basically, since I have created 2 different pipelines for historical and incremental, I am mentioning the folder name statically. That is, if my pipeline is running for historical load, then my container will contain historical subfolder in it. If we go to incremental, you will see sales analytics / increment. Moving further, so similar to the source data set, I have declared 2 parameters and I have initialized them. One is for the folder name that I want to place the file in, so that if I am trying to copy for products table, the products file will be placed inside a folder named products. So and the other one is for the file name, the actual file name that it has to be given into. So this is how I have provided the parameters dynamically. So when we run the pipeline, it will take these parameters and it will create the folders and create the file names while copying the data from SQL database to ADL as Gen 2. Similar to historical pipeline, incremental pipeline also does the same, same task of copying the data from source to ADLS Gen 2. So what I'm doing is that once the copy data between source SQL database to ADLS Gen 2 completes inside the historical pipeline, I have attached an pipeline activity at the end which will execute the incremental pipeline. Rather than triggering manually, I have attached the next pipeline that has to be triggered, so that when this pipeline, when this activity starts executing, which means the associated pipeline, that is incremental pipeline, starts executing. So the incremental pipeline also does the same, similar to historical pipeline, that is taking the output of this lookup activity to for each activity and iterating over the output of this lookup activity records, and iteratively copying the data from SQL database to corresponding folders in ADLS Gen 2. And at the end, again, I'm executing the actual pipeline, that is my Databricks workspace notebook pipeline. So before moving any further, let me show you how I'm achieving the task of doing the transformations on the data that I have extracted from the source. So this is my notebook activity, and I have created a link service which will connect to my workspace. Let me test the connection. Yeah, it is saying connection successful. It is same as creating a link service to a particular source in all the other activities. So it's not much of a big deal to create this notebook activity, provided that you have a set of notebooks or corresponding notebooks in your workspace. So this is my workspace, and actually I have started the cluster ahead. So this is my cluster, the two nodes, two worker nodes, and two worker nodes and one driver node. Yeah, see, I have one driver node and two worker nodes. And let's go to the jobs, or let me show you the jobs, how I organized the notebooks and how I created a job. So first I'll show you one notebook, sample notebook. If you can see here, just ignore these two, these set statements for time being, because I'll explain them at the end. So basically I have created a data frame prior to this notebook, that is in another notebook. Let me show you first, sorry. Yeah, so this is the first point where my actual PySpark code starts. Actually, there is another notebook that will execute these set of notebooks one after another, but for time being, this is the main or initial point where my actual Spark code starts for doing the transformations. Initially, I have created some schemas, form of files, and I have created some data frames, and as you know, we have some files that have been dropped into ADLS Gen 2 historical and incremental folders, from where I am picking up the data and reading them into data frames. And later, in order to use SparkSQL, I have to create a global temp view or a temp view in order to use them in multiple notebooks or within the scope of this Spark session. So first I have created the data frame, and later have created global temp view, as I'll be using not only in this notebook but in multiple different notebooks across this current Spark session. So instead of creating create or replace temp view, I have created a create or replace global temp view. That's the main difference. And once these global temp views are created for each and every data frame, I'll be using these global temp views in multiple notebooks wherever they are necessary. So once they are created, I'm ready to use those global temp views anywhere across the Spark session in multiple notebooks. So coming here, ignore these two set statements, I'll explain them at the end. So I want to store the output of my Spark SQL code inside a data frame so that I can write the output of this output of the SparkSQL code to an external storage or whatsoever the output source. So this is my actual SparkSQL code that will be doing some operations. And yeah, so this is my and one more thing is, in order to use the global temp view that you have created earlier, you have to always use global underscore temp as prefix or like a schema in order to access it. Otherwise you will face an error while executing the code. So, and I have stored the result of this SparkSQL code into df underscore products data frame, and I'm repartitioning it. The logic here is, I can if I'm trying to reduce the number of partitions of output data frame, then I can use curlies, or if I'm trying to increase the number of partitions, that is if I'm having one partition and if I want to increase the number of partitions, then I'll have to use repartition method. And once the repartitioning is done, I'm trying to write the output of this SparkSQL code whatsoever that I have obtained to an external source, that is different folder inside the same container of ADLS Gen 2. That is, as you can see here, sales folder, transform data, and these are the different folders. If you can see here, sales / transform data / dim order payment info. So I have two different files because I have changed the data frame partitions to 2 by using the repartition method, right? And basically Spark by default doesn't have any built-in method to provide the file name that it has to write. By default it will write it something like part -00 something like that. But since I don't want my file names to be something like that, I'm using some built-in methods provided in traditional MapReduce to rewrite the file name to the corresponding or the required file. You can refer to my GitHub code for more clear explanation about this. And this is one of the notebook, and this is my fact notebook. I have organized these notebooks in such a way that I want to store the output of these files into a data warehouse, like a fact and dimension model, fact and dimensions, like a star schema. So this is the fact table SparkSQL code that I have written, and I want to store the output of this in a single partition, so I have repartitioned it to 1. But also I can use queries rather than repartition. Sorry. Yeah. So as I said, if you want to reduce the number of partitions of your data frame, then you can use queries. If you want to increase, then you can use repartition. And this is my SparkSQL code for fact table, and you can go deep into the code, what exactly is happening from a GitHub repo. And similar to the previous notebook, I'm trying to rewrite the name of the file that is being placed into blob or ADLS Gen 2. And I want my file name to be fact-sales or the same name as the file notebook name. And similarly, there are 2 other notebooks which will do the similar kind of activities. And once I have created the notebooks, I'm trying to execute them from a single notebook. That is in this notebook. I'm using DB utils, that is Databricks utilities, which are provided to run the notebooks. So yeah, initially I'm trying to run the sales flow data, that is which will actually create the initial data frames and global temp views. Later, if the initial data frame created is successful, only then I want to go further. Otherwise, if it is not ran successful, there is no point of executing it or moving further, right? So I just want to make sure whether my data frames and the global temp views that are created are successful or not. If so, then I'm trying to run the next notebooks, that is the dimension notebooks. Like first I want to execute the dimension notebooks, and later I want to run the fact table notebook. So I'm running it by using dbutils.notebook.run, and I'm taking the output of I'm sending some output at the end of each and every notebook using dbutils.notebook.exit of message. So when the notebook completes its execution, it will return something, and the message whatsoever is returned will be stored into this variable notebook here, notebook B, and notebook C correspondingly. And once these three notebooks are done, I'm checking whether the output that is being returned is same as the messages that I have written here. If so, then which means my dimension tables are successfully transformed. Like whatever the logic that I have provided have been successfully completed without any error. So it will display the message dimensions are done, as you can see here. Similarly, once the dimension tables are done, I am trying to execute the fact table notebook, and similar to the previous cell, I am trying to return some message from the notebook, and it will be stored in fact table. And if the message is same as the one that I have provided, it will print fact table then. If there is an error, it will say fact table failed, just like that. So I'm done with this. Since we are done with creating the notebooks and orchestrating them using one notebook, I want to create a job. So in order to create a job, just go to jobs and click on create job. It will take you to this page. You can provide whatever the name you want. So you can sales. Yeah, that's fine. So you can select the notebook which you want to run first. So I have organized these notebooks in a folder structure. So to the sales underscore initialization notebooks, and my first notebook should be sales or data flow orchestrator, right? So if I click OK, it will create. Yeah, and this is the first notebook that will be invoked, which will automatically invoke the internal set of notebooks that which we have seen earlier. And again, we can select the cluster. Actually, it is selecting for a new job cluster. Rather, you can do one thing. You can select the existing one. For time being, let's leave this because I do have a job already in place. This one, see, the same notebook, and I have selected the cluster sales. It is up and running right now, and you can schedule it when you want to run on a daily basis or a hourly basis or whatsoever, and also select the time, the UTC or IST or Pacific time or whatever the time zone you want to, and you can schedule it, and it will be executed on that schedule basis. And you can configure the alerts. So if a particular notebook fails, then you can send a mail to that particular email ID saying that this particular notebook has failed at so and so time, something like that. So you can configure the options whatever you want, and actually you can click run now apart from your scheduled time, so that you can just check whether your notebook is perfectly written or not. Yeah, it's running. Let's click on that and see how it's running. So the first notebook has started running, that is which will execute the notebooks internally, right? So it takes hardly less than a minute to complete the entire execution, as per my previous knowledge which I have on this notebook. So if we are good with executing this one, then our notebook is running successfully, so that we can use this particular job, we can refer to this particular job inside our data factory activity. So basically it should refresh automatically. You can select code or results only based on your requirement. He's saying it's failed. Let's see why. Let's see code. Okay, let's go to the notebook and debug what exactly is the error. It is saying path does not exist. Oh, sorry, actually we don't have any data, right? So in order to run this, we need to have some data in our data lake storage, right? So let's run the pipeline directly rather than doing all of this. So basically, I have full confidence that my code is clear and running. So let's come here. Actually, I have linked my notebook to this activity. Okay. See, I have selected my notebook here. It should provide my notebook in my Databricks workspace. Let me show you how. So it is in shared. So it's not in shared. My bad. Users and yeah. So under init, I have my notebook, that is sales data flow orchestrator. So when I invoke this notebook, it is internally invoking the other notebooks, right? So if I select this one, that's enough. It will this activity will point out this notebook, and it will start executing the set of notebooks one after the other by creating a cluster, or if there is one already existing, then it will use the existing cluster. So let's don't waste our time, and let's execute our first pipeline, that is historical, which will automatically invoke all the other pipelines. Done. Okay, so it started running. Let's go to monitor session. Yeah, you can see here it started running. Let's refresh this. It's cured. Okay, let's wait. Yeah, the lookup activity is complete. Let's check out what is the output of this lookup activity. As I said, first when we are trying to copy data for historical data, historical tables, we are trying to retrieve the records from SQL database, only those records that are having low type as H, right? So we retrieved 3 records. So we have the count 3 and the 3 records values. Okay. So we will feed this output to for each activity. So in each and every iteration, it will take, as you can see here. So inside this for each activity, we have our main activity, copy data activity, right? So this for each activity has taken the input from lookup activity. See, item count is 3, and we'll use item function internally inside the copy data activity. So as you can see here, the copy data activity has executed 3 times, because in each and every iteration, the copy data activity inside the for each activity is taking one record output of this lookup activity. So let's see what is the input here in this activity. Sorry, it is not mentioned here. I think we are good here. Why not waste time? Let's go to the next pipeline. Parallelly, let's check our let's enter location. Yeah, if you can see here, previously I have deleted the historical and incremental folders. Now the pipeline is successful, and I have the data in place, right? So let's delete the sales so that we can have more idea about what exactly is happening. See, okay. Oh, Databricks notebook is also completed. Sorry, let's refresh this here. My bad. Actually, I have deleted the sales folder that is created now. My bad. Let's do one thing. Let's rerun this pipeline, or let's do one thing. Let's delete everything. and let me hit on the historical pipeline again. So let's go to monitor session. So let's monitor now. Yeah. Okay. The main copy data activity is in progress, I guess. It is in queued state. Okay. It might take a few seconds. Yeah. Copy data is complete. For each is complete. So it started executing the next pipeline, that is incremental pipeline. See. So incremental pipeline is also in progress. Yeah, the for each activity is in progress, which is the main copy data activity. Parallelly, let's check our storage account. Yeah, historical data is here. We are good. Now refresh here. Okay, the copy data is in progress for the 3 tables of incremental load type. Let's refresh once again. Yeah, it's taking some time. Let's wait. Okay, it's taking some time. I'm not sure why this is. Yeah, it has completed for 1 table. Let's refresh once again. Yeah, completed copy data for incremental tables, and it is executing the Databricks notebook. Yeah, good. And now come here. Let's monitor what is happening. Okay, it is waiting for Databricks cluster to be ready. Let's refresh this. Yeah, the Databricks cluster is ready. Let's click here. Now this will point out to the page where our jobs are running, and now we can monitor where exactly our job is in progress. You can see here it completed till here, I guess. I think it has completed loading till here, till dim order payment info, because it has completed 3 notebooks, right? Before, we have actually 4 notebooks inside this first cell, so out of which we have completed 3, and the last one is remaining, I guess. Okay. Yeah, it completed. It is saying command took 0.10 seconds. And we have the final notebook. Yeah, it is saying dimensions are done, which means the dimension notebooks are completed. See, it is saying fact table done. So we are good here, which means our entire facts and dimension tables have been transformed, and now we should have our data here. That is, yeah, if you can see here, we have the data, transformed data into the corresponding folders, right? Great. We have data. Good. Yeah, good. So let's check for another file. We have the data. And let's check fact tables also, so that we will be happy enough to know whether we have done properly or not. We are good. So this is how we accomplish the task of doing some ETL transformations using Azure Databricks and Azure Data Factory. We use Azure Databricks to do some transformation logic, apply some transformation logic, and we used Azure Data Factory to orchestrate a pipeline, starting from extracting the data from source, transforming them, and again loading them into our destination. Now we can use this data from ADLS Gen 2 to load it into our data warehouse or database tables or whatsoever tables that we have, and send it for reporting or data analysis or whatsoever that are required. So that's it for now, guys. Thank you for watching. If you like the video, hit thumbs up and comment if you have any doubts. Thank you.